how much time has elapsed according to Big Bang theory? 14.3 billion years. Roughly in 2 to the power something, everything we are doing is 2 to the power x. So this is what I have calculated. This comes to around 13.799 plus minus 0.021 into 2 to the power 30 years has passed. That roughly equals to 2 to the power 34 years. Now, in order to solve a tiny problem, we need to wait 2 to the power 895. How many big bangs has to occur? I don't know. This is exactly this particular workshop is all about. The problem is not with the computing power. The problem is not with the computing power. Computing power, if at all you realize, the computing power has been stagnant for almost a decade, or even more than that. It's almost stagnant. What is important is algorithm. The brute force algorithm that I used here is going to take you nowhere. I hope this makes a little bit of sense about this particular workshop. Earlier, Madam Oja was telling about AIs and all those things. I don't recall where exactly I got this particular image. Somewhere in the internet I got during the COVID time when I was quarantined. So this is something fascinating actually. We are here. Artificial narrow intelligence. This is what she was talking about. If at all you have heard. Artificial narrow intelligence. We are at this stage. There are three kinds of intelligence he was talking about: artificial narrow intelligence, artificial general intelligence, and super intelligence. We are located somewhere here. Smart city is not yet realized. Somewhere here. Since just read this. Each one of them is so enthralling. Maybe we may not be alive to see all these things. Maybe not. Look at the last one. Radical light extension. And its predecessor is de-extinction. Think about this. If we can somehow bring back our forefathers and do something there. Now, just going back to this particular problem. Let me give you few of the insights. Actually, for the last 2 years, 2022 and 2023, by the Ministry of Education, Government of India, NIT Rourkela has been entrusted for the Central Seat Allocation Board and Joint Seat Allocation Authority. So, I am the Vice Chairman there, looking after 119 institutes across India, out of which 23 IITs are there, 32 NITs are there, 26 triple ITs are there, and few other government-funded technical institutions are there. So why I am citing this particular example is again related to the computing. And what a coincidence. Long ago, it was around 2012, at that time also IWR Club was interested, and we were hosting this for the first time. Mani sir was also part of that. I was newly inducted into that part, and our responsibility was to perform the allotment. We wrote an allotment program in a very short time, without understanding anything, without understanding the gravity of the problem. I ventured into the problem and started writing the program. And trust me, at that time, it took 29 hours to execute that one allotment. 29 hours. 2012, you might be in the schools, but the fact is 29 hours it took to run one allotment program. So, as you know, between one round and second round, there are some time gaps are there. At that time, 5 days or 6 days of time gap used to be there. And 29 hours, more than a day. And after 20 hours, you realize that, oh, I made a mistake. So again, I start from zero. So this is how it used to happen. What was the problem? The problem was the algorithm. It was not the computing power. We had the best computing power at that time. But it was all about the algorithm. How we are attacking the problem. Now in 2022 and 23, we are solving the same problem, even much bigger problem. The magnitude, the number of students, the number of candidates have grown to many folds. We are solving the same problem in 5 minutes. Believe me, it is only 5 minutes. The reason for that is a Nobel Prize award winning algorithm called deferred acceptance algorithm. Anybody of you have heard about it? Deferred acceptance algorithm? Please read it. Wonderful. Nobel Prize award winning algorithm. So that 29 hours has been reduced to 5 minutes. And I believe it can be reduced to 5 seconds also, provided I work more on the data structure part and the algorithm. So why I'm pointing all these things? You forget about all this AI and all this. They're all, forget it. Stick to your fundamentals. Stick to your fundamentals. Stick to your fundamentals. That is more important. AI will come and let us talk about fundamentals. Let us multiply 2 matrices. Can I multiply this 2? Right? The multiplication norms it holds. How do you multiply 2 matrices? One of the matrices is 2 cross 2, the second matrix is 2 cross 1. Very much I can multiply. How do you multiply?
Row first.
Row, first row and first column. Then the second row and the first column. That is how we multiply. Forget it. Forget it. This is going to nowhere. What kind of understanding it has got? Let us multiply column by row and let us see how it works. That gives you an understanding. Row times column. What is the significance of this? You talk about this machine learning and all these things, everywhere matrix things will come. But what is the explanation of that? How do you understand? How do you comprehend that? Row times column will give you no understanding. I don't know, maybe this is the legitimate way. But let me give you my way of teaching, that is column times row. Will this work? Will it give the same result?
Yes, sir.
Say yes or no?
Yes, sir.
Yes, it will give the same result. Now let me give you the understanding of this. In order to understand this, you need to understand what is a vector. Tell me, when did you know about vector first? From which book you studied about vector? Yes, which book? Bharita Sharma? Which book? Matrix. Patrick's, from Patrick's you studied. Okay. I studied vector way back in 12th standard. For the first time I heard. You might have heard even earlier than that. So what is the meaning of a vector? What is the meaning of a vector? Vector is something, a quantity which has
Certain
two
direction.
quantities. One of them is magnitude, another one is the direction. Fine. That is what the physics people say. That is what the physics people say. What about mathematics? Mathematics people say vector is something else. And computer people say vector is something else. So what about mathematics people? There are so many mathematics guys here. Tell me, what is the meaning of vector from mathematics point of view? It is not direction and angle. It is something else. What is vector?
The number of dimensions it might represent.
Number of dimensions that's present in a row vector. So each element gives you a dimension. Now, from computer point of view, it's somewhere in between. They say that it's a column vector, one-dimensional matrix, we treat it as a vector. But now, the point here that is to be understood, are all these three different? Physics, mathematics and computers, are all these three guys talking different languages? They're using the same word vector, but are they talking different? There must be some commonality among them. What is that commonality? You try to understand that commonality, you understand this. Make a wild guess.
It is one dimensional.
Yes?
It is one dimensional.
Which one?
Vectors in all computer physics and mathematics.
No, it's not one dimensional. You can go to infinite dimension also.
But a particular vector would have one dimension. It's just a guess. I'm not sure about it.
If a vector is one dimensional, then usually we call it as a scalar quantity. Right? Scalar, vector, we call all those things. So, if it is only a single number, single digit, not single digit, single number, then we call it as a scalar quantity. Scalar comes from scale. We scale something, multiply something, and elongate it, shorten it. That is how it is. So, given a vector with a magnitude and direction pointing towards that, we shorten it, elongate it. That is what we do with the scalar quantity. But then the point that I asked you is, how do we find the commonality? How do we understand the vectors from mathematics, from physics, and from computing? In fact, all these three are the same. There is no difference among these three. Which job cluster is actually required now. Given x-axis and y-axis, how do I represent this AC? AC. If I say A denotes the distance traversed along x-axis and C denotes the distance traversed along the y-axis. So the resultant distance, that actually denotes the vector. That is how it is represented, right? So along x-axis you have traversed a unit of distance, along y-axis is c unit. So the resultant is, that is the vector a comma c. Now you extend this one to any dimension, the same thing works. Now in the case of physics, you are telling it's the magnitude and the direction with respect to x-axis. In case of mathematics, you are not talking about the direction explicitly, you are not talking about the magnitude explicitly, rather you are talking in terms of a matrix, in terms of a vector, that is A and C, and rest of the things you are keeping abstract. That is what mathematicians are very good about, keeping everything abstract. They love it very much. So they keep this x-axis, y-axis, and how much you have traversed, all these things abstract, hidden, so that nobody can understand. And A unit you have traversed, C unit you have traversed, and that is how. Now the same thing, physics and mathematics. Now when you come to the computers, they actually try to put all these things in the form of a memory and fit it and try to program it and try to do some miracle. All this AI, artificial, natural intelligence to build all these things they do. So when they do this, they actually put this one in the form of an array. That is what we call it. In the form of an array they put. Whether it is a one-dimensional array or two-dimensional array, it's basically one-dimensional array. Now, having understood what is vector, let us try to understand this matrix multiplication. And it's all about multiplying. It's all about scaling a vector with a scalar quantity. Vector a comma c has been scaled with a scalar quantity x. There is another vector b comma d has been scaled with a scalar quantity y. And these two vectors are added to form a resultant vector. Does it make sense? I am not multiplying using row times column. It's column times row. Well, so a comma c is one vector which is scaled by x. B comma d is another vector which is scaled by y. These two are added to form a resultant vector. Resultant vector is ax plus by, cx plus d. With this is the first step of linear algebra. Now extend this one to what is a span. What is a span? What is a trace of a matrix, span of a matrix, and many things are there. So those things will come into picture. Once you try to understand all these things, your understanding of all those machine learning, AI, everything will be like this. Stick to your fundamentals. Okay? Now let me review you from the fundamental to the kind of business that I do. Low light vision. How to see in the dark. Yeah. What you can see, something is visible, right? Your display device is good. That is why it is visible. Something is visible. In my laptop, it is not visible. Is it visible, right? So something about night vision, this is what we do. Now, before I jump into this, is there any question till now? All those fundamental stuff and why it's actually necessary. The algorithm, what is necessary. By the way, nobody asked me what is that deferred acceptance algorithm and how it actually works. What is the magic in it? That it can solve in 5 minutes. It's not just deferred acceptance algorithm. It is like a combination of deferred acceptance and a little bit of data structure and a little bit of pointers, C language and all those things. That's what the whole synthesis is. And that is how we are able to solve it, allocate it within 5 minutes, and the results are published within a day. So the common question comes, if you can solve it using 5 minutes, why you are waiting for 24 hours? It's not about the machine, it's about the humans. For humans only we wait for 24 hours. In an automation system, Mahisa is very genius about this actually. He prepared lot many things in the we are actually using still those systems. So in an automation system, what happens, human intervention in a series of steps, everything is automated, it will work perfectly fine. The moment you introduce between step n and step n plus 1, you introduce a human intervention. That is where all the flaws will come and all the delays will happen. And between round n and round n plus 1, in the kind of allotments you are subjected to, there are human interventions. Your certificates are being verified, whether you're paid or not, the fee. There are so many things out there, so many human interventions out there. So the moment human intervention comes, everything gets delayed. And that is why 1 day has been kept. Just for the sake of shock cushion. Otherwise, the result can be published the moment round n finishes. Next 10 minutes, we can publish round n plus 1. But that is what the problem is. Now come to the algorithm. How does it work? This algorithm, if you go through, it is actually best explained like there are 1, 2, 3, 4, 5 so far seats are there, and there are 100 students are in the line, in the queue to occupy that. So the number of resources are limited and the number of aspirants are pretty large. In such a scenario, this kind of deferred acceptance works very beautifully. So it's something like, let us say 5 seats are there, 5 engineering seats are there, 5 science seats are there, 5 seats are there, and there are 100 students waiting in the queue. So you allow the students, right? You come and take whichever seat you want. Whichever seat you want, you take. But with one condition. Next time, if a student with a better rank comes, then you have to relinquish the seat. The whole algorithm is this much. You come and occupy whichever seat you like. Whichever seat you like. But the next time if a student comes with a better rank, then you have to relinquish the seat. And this process continues. This process continues as long as there is no relinquishing of seats or there are no students left. And this is such a wonderful piece of algorithm that actually solves the entire problem very quickly. Please read it. So it is not about the hardware, it's all about the algorithm that has to be mastered. Now, if you study the different paradigms of algorithm, there are 5, 6 paradigms of algorithms are there. So those who belong to computer science might be well versed with that. Maybe the kind of algorithms, maybe the kind of examples that are given may not ignite your mind. But think from the example that I gave you, 2 to the power 1000, number of candidates appearing. Just for the sake of record, this time we had more than 2 lakh, this time we had 11 lakh students who appeared NTA JEE Main, out of which 2 lakh students, this 2023 statistics actually, out of which 2,16,000 students participated in the JOSA stage allotment process. Those 2,16,000 students filled in 2,51 lakhs, something little more than that, number 57,000 seats, 2 lakh students, 2.5 crore choices. This problem is a smaller problem actually. If I talk about the problem like bioinformatics, where the number of possible combinations are more than 4 billion, 6 billion human gene expressions. More than 6 billion. Here, 2.5 crore is a small number, isn't it? Compared to 6 billion. Now, why to talk about only humans? Why don't we talk about animals? Then it's much more. Now you realize why COVID was so dangerous. Okay, any questions so far? Thank you. Yeah.
डिलीट करके को रखना उड़े देते हैं कुछ रखे हुए खाली कर दो अस्सी जो कुछ हम तो ना बात नहीं
Yes, just now you told it. It's true. And 2012 it was awarded. It was Nobel Prize. Yes. But as you rightly have pointed out, it's not the same algorithm we have directly applied. As far as the problem is concerned, we need to modify it a little bit and then we can divide. That is how it is applied that. That is the problem. Obvious.
Can we apply it?
Can we?
साइड से
Yes, why not? Model, you need to model the problem accordingly. You need to model the problem accordingly.
It's actually a timetable system,
Yes, rightly said.
very constant. Some people want that I will take morning class, consecutively 3 classes. Some people will tell that they will take Friday, Saturday off. So there are a lot of constraints. Preparing timetable is very difficult.
Yes.
So
So when we read the books, this timetable example, your exam schedule example. So these examples are very common, and this actually gives the understanding of the problem. Then its application is far more. So if you recall, those who belong to computer science might have heard about NP complete problem, NP hard problem. So majority students might have also come across these terms, NP hard problems. These are all different NP hard problems actually. that is need to be solved. But then how do we approach the solutions towards NP hard problems? NP hard problems are intractable, that is for sure. But then how it is approached? It is approached like there is another solution which is available in another problem domain, and you try to remodel it according to your problem and approach it and make a reasonable solution out of it. So that is how it is approached. So those who are studying NP, NP hard, NP complete and all those things try to relate everything to this. Okay.
This low light vision. Low light vision is linked to this, sometimes some queries come that will find the picture. Some picture, some imagine that product should be actually animal or some tree or some mountain like that. It belongs to that kind of thing.
Actually, I started working on this particular problem during the COVID time, okay? And experience came from the. I've been working in surveillance, video surveillance, for quite some time. Immediately after my PhD, I started working on video surveillance. Then, in Raukila, they entrusted me a job to put surveillance cameras throughout the campus. So in the first phase, we put surveillance cameras in the different gates. So there I came across one particular scenario. If you have come across this. Surveillance cameras, they sell with lots of fancy names. And one of the basic requirement for a surveillance camera to function is decent lighting condition. Unless and otherwise you have decent lighting conditions, surveillance cameras are doomed. And particularly in gates, entrance gates, where fancy lightings are put. Fancy lightings are put just to decorate the things, and it is VSS UT Bulla is no exception. Everywhere it is there. It's most common. Fancy lightings. So those fancy lightings, what is the lux level in those fancy lightings? Are they adequate for human beings to be recognized by another human being and human beings to be recognized by a machine? There are differences. We humans are blessed with wonderful pair of eyes that with having a very wide range of dynamics that can capture even in the dark itself we can understand who is there, who is not there. But this is not true when it comes to the camera. And one of the examples that I have given here is this. And that is where actually I started working. And these are some of the examples. Low light. This is the corresponding better light picture. Our eye is one of the most complex organs, even animals also do have. So at night time, the illuminance level is very low. It falls below the standard. And that is where different complex things actually happen. The brightness is low, the contrast is low, the gray range is low, there is a color distortion, and there are considerable amount of noise. Now the point is, what are all these things? What do you mean by brightness? What do you mean by brightness? Nowadays, each one of you are having a camera. What do you mean by brightness? What do you mean by contrast? Have you ever asked yourself? What do you mean by brightness? Those who have used Rohini Deluxe, they might have used brightness, contrast quite often. But nowadays those things are not there. I mean, it's pretty much automatic. So, what do you mean by brightness, contrast, gradients, color distortion, noise, and so on, so on. So, whenever you take a night vision, whenever you take a picture in the night, these are the complex phenomenon that actually takes place, and your pictures are actually supplied with all this. Now, let us talk about again fundamentals. What is a candle? What is a lumen? What is a foot candle? What is a lux? SI unit. So, among all this, foot candle is one of the important part that I need to say. Foot candle is the original measurement system of light intensity. If there is a candle, you capture the intensity at 1 feet distance. There is foot candle. A candle, whatever amount of light is emitting, you capture it at 1 feet distance and you measure it. That is what the foot candle is, and its corresponding SI unit is lux. Just to give some random pictures from the internet I have downloaded. These are some of the foot candles that is required in our offices. Everyone is fascinated about LED bulbs, low wattage LED bulbs and everything. But actually they forget how much of light actually it is emitting. And believe it or not, kitchen is one of the most lit up room. Usually it has to be something around 40 foot candles, but it's far less than that. You go to your house today and you can find it out. These are some random examples. This is what the work that actually we are trying to do. Dark level, we say 0.01 lux to 0.1 lux. Moonlight level, 0.001 to 0.01 lux. And starlight level, it is less than 0.01. If there is no light and we are trying to capture a scene, so how do we capture a scene without light? What are the possible ways that we can capture it? Actually, our target is this starlight level. A scene is captured under the starlight level, and how can I improve it so that it's worthy? It is having some scientific value. Now, let us talk about brightness. Overall lightness. Now look at this particular image, if it is visible properly. Here the image is, I have taken from one of the book digital signal processing. Here the brightness is too high. The whitest pixels, white pixels have become whiter and whitest. Brightness is too low. Here the dark pixels have become darker and darkest. Here look at the contrast. The contrast is too high. Black becomes too black and white becomes too white. And this is another picture where the object splits into each other. So these are the four scenarios, common scenarios. Just to understand it, do a little bit of experiment. Take one 32 cross 80 pixels size and 3 squares in it, and fill it with gray values 75, 150 and 225, and inside that 2 triangles. In each square there are 2 triangles. 75 is the common gray value, and the upper triangle is little less than that, lower triangle is little more than that. Similarly, 150, 146, 154, 225, 221 and 229. So strategically placed, 75 is the middle value, little less than that 71, little more than that 79. Now this is how the image is prepared. Now let us see how the image looks like. How many of you can recognize the triangles? Can see the triangles? So those who are raising, can you see all the 6 triangles? Very good. You have got big eyes. You have got a very good pair of eyes. Those who are not able to see it, they might be having a little bit difficulty.
If someone concentrate, then after some time it will be get noticed.
Yeah. So you need to, your eyes need to little work hard and see whether it's possible or not. From here I am not able to see. From farther little bit it's possible. So the whole problem is this. Entire problem is this. Right? I have explained, trying to explain what is brightness, what is contrast, and how to improve that. That is the whole point here. So how do I improve? If these are the input levels on the x-axis and this is the output levels, and let me assume that whatever is the input that becomes the output, a perfect 45-degree line I get. Input output. Now, little bit of trick I will do. Very minor tricks. What I have done here, from 0 to 100, the input values, for 0 to 100 input values, the output is 0. The first square, the values were 75, the first square values. So those became black. Second square, it was 150. Now 150 has come down to 50. 150 in the input has come down to 50 in the output. Brightness has been lower. And the third one, 225. 225 has come down to 125. So that is how the things have been manipulated. Increased brightness. Brightness has been increased. So input value 0, output value 100. So 0 becomes 100. From 0 to 150, I am putting it in a linear way, and from above 150, everything is saturated to 255. Now that is what the image is. I am not able to detect the triangles anymore. Is the triangle properly visible now?
Only the first one.
First triangle. First pair of triangles. The trick is very simple. Between something around 40 to 100, the input-output slope is stiff, and rest of the things I don't care. So I am able to understand that there are two triangles in the first square. Now same thing I can do it for the second square. Same thing I can do it for the third square. And easily I can recognize that there are two triangles of different intensities. So can it be programmed by you? Can you program it? Can you write a piece of program so that this thing can be achieved? So you take your grandmother's photograph, increase her brightness, increase her contrast, and do things. It's very simple. What you need to do is take all the gray values on the x-axis. So for each gray value, what should be the corresponding output gray value, you decide. You decide. You write a program for that. Still better, huh? Yeah. So these are all very basic fundamentals that are there in the image processing, any kind of books you find, any image processing books, computer vision books, very fundamental things that are there. Now, what is there in the low light then? And essentially, if you see at the bottommost level, this is what the low lights are. But maybe some other day we can talk. Time being very short. How much time do I have, sir? So, yeah. Now, the same thing you try to put, same concept, you try to put inside in a tank, same concept you try to put in night vision goggles, the same concept, and it works. Little bit of differences are there, but it's not exactly the same concept. Whether you talk about military applications, whether you talk about wildlife applications, safety, security, navigation, the night time, some industrial applications. So, little bit of twist is there. It's not directly you can apply all those things. Directly it cannot be applied. There are two broad night vision categories here. One of them is spectral range and another one is the intensity range. Spectral range, as the name suggests, we have a limited band of frequency in the electromagnetic spectrum. We have limited band, somewhere around 400 to 700 nanometer, that is, we all are able to see. Now, during night time, if I am being bestowed with certain gifts, like I can see in the night time also beyond the electromagnetic visible spectrum, then definitely I will be able to see, say for example, infrared, near infrared, or X-ray. Let us say I am having, my eyes are equipped with X-rays. I will be able to see your bones also. Yes. So, spectral range, kind of night vision approach, it tries to improve upon the range of frequencies that we actually see, we actually do not see. So, human vision is actually confined to a small portion, and hence spectral range can allow the viewers the advantage of seeing beyond the place. Now, yeah, but then some of the animals are well equipped with this. When it comes to intensity range, whatever is given to you, whatever is supplied to you, you use that and improve upon it. That is what the whole intensity range is. Most of the night vision goggles that military applications, those people actually wear, are based on intensity range. If it is absolute dark, those goggles are not going to work. Those goggles are not going to work. If there is little bit of light, at far distance a candle is glowing. Let us assume that. At far distance a single candle is glowing. If that much amount of light is there, then this intensity range also works fine. How? Those electrons are being amplified, and some calculations goes on. I'm not that much conversant on this. That improves the lights, and you can able to see that. So a range of intensities are being improved upon to actually visualize the night vision things. In addition to this, there is something called thermal imaging. It actually creates a temperature difference between the different bodies that are there and its surroundings, and that you can able, from the temperature difference, you will be able to see what are the things there. Now, these thermal images are actually essentially infrared images. But if you see the infrared spectrum, yes, this infrared spectrum. It is at the far end of the infrared. But those who have already registered their Aadhaar cards might have registered for this, they must have acquired your iris signatures. While capturing the iris signature, they use near infrared imagery, and near infrared imagery would be somewhere here, just after the visible lights. Just after the visible lights, whatever wavelengths are there, those are being used. Whereas in the case of thermal imagery, it is the far end of the infrared that is being used. Now coming to the near infrared, this particular camera, which is here, I mean, some at the night time you might have seen some reddish color lights, it glows. Those are actually infrared, not infrared, and those infrared are the just after the visible spectrum red color. It's a red, right? This is red, and the next to red is infrared. So those colors are being used. And yeah, this is something, the light amplifications things that I was telling you. You have a dark image, some little bit of light is there. So these electrons are multiplied over, and a large number of photons are created to find the final enhanced image. Okay. What are the different enhancement models that are being used? These are different models. We did a little bit of literature survey a couple of months ago. So, gray transformation, I have already talked to you about what is the gray transformation, what is the histogram equalization. You take a photograph and click autocorrect in your mobile phones. So this autocorrect things is actually histogram equalization. Then there are other methods like Vertinex method, frequency-based method, fusion methods, de-hazing, de-dusting, and some deep learning methods. So maybe if we start talking each one of them, it will take very longer time. So these are all the areas that are there in mathematics and computing, and that's all I have for you tonight. If there is any question, please ask. What are the last figures that, let us see that figure, some of the results that are there. Is there any improvement here?
Yes, Santos uplifting.
This is again standard algorithms, histogram equalizations. This is again some Retinex methods that use. So we have come to the end, sir. I'm just going through the different images that we have. That's all. Yeah, this is the last one actually. On the left hand side you have the original image, and the same image is subjected to some object detection, and nothing is being recognized, very little things, very small object, less number of objects are being recognized, and with the help of the enhanced images, more number of objects are being recognized. And this is absolute dark images where the light source that we have are from the glow signs that are there, and rest of the places there are absolutely no light source. So that is what the whole point is. Without light source, or the light source as low as moonlight or starlight, how to get back the pictures. That is the whole point. That's all. Thank you. If there is anything to ask further, you have asked many questions, but then there is still any more questions, please ask. Yes. These algorithms you are telling, these are all the literature survey that we did actually. All these algorithms have been used. Sorry. Yeah. These are the different set of algorithms that have been used. Different methods, different in the different ways that have been modeled, and they have been solved. As of now, it's data transformation, everything is depending on the scenario. Depending on the scenario, it's like when it comes to this kind of images, the primitive algorithms, whatever are there, histogram equalization and gray level transformations, these algorithms do not work here. Here actually you require deep learning models. Whether the Retinex models or deep learning models are required, where actually we try to study similar kind of images from normal light, and also what we are trying to do here is trying to fuse thermal images so that it can give us better. Not much depth has been there. We are into this.
Sometimes low light vision is very good than normal vision.
Yeah, that is what, when I started talking, actually talking about the slow light vision, I gave you an example how in Raukla we faced the problem of while installing the cameras in the gates, all those fancy lights, how it actually creates the problem. If at all you have crossed the toll booths, whenever you cross the toll booth, you might have seen there are a number of cameras are there. One of the camera will be seeing the driver, one of the camera will be seeing the license plate, another camera would be seeing the loads that are there on the back side of the truck. So front, back, top, bottom, everywhere they will be observing it. And that is the ideal scenario. And each of those cameras are calibrated well to understand what actually the license plate, what is the number there. Now think of a situation, I am holding a placard here and you are able to read it. Now along with this placard, I will put two headlights, two torch lights I will put and put it on your eyes. Will you be able to read the placard here, what is there? The same thing happens in the license plate also. In the license plate, car license plate or truck license plate, license plate is there, and on the left and right hand side, two headlights are there. Now the camera gets fused. When the level of lights that is there in the daytime and the level of lights that are there in the night time are completely different. And this is where the actual problem comes. And they, in the toll booths, they actually calibrate the cameras for each and every scenario. But when it comes to educational institutions like yours and ours, with running short of money, some innovative solutions are required. That once it becomes 6 p.m., switch the mode. Once it becomes 5 a.m., switch another mode. So like that. So different innovative solutions are required. Along with that, innovative algorithms are also required.
Mostly